Welcome to a video discussing section 2.5, which is about using properties from algebra. If we take a look at the warm-up exercises, we want to solve for x. Oh, let's make that a little thicker. Here we go. That's right, we want to solve for x. So as we know, add 3x to both sides. So you can combine the x's. Then you want to subtract 2 from both sides. Combine the constants. And then divide 9. Now, if you think about it, this illustrates 3 steps. And I can kind of separate it like this. So clearly the first step was combine the x's by adding 3x to both sides. Then the next step was subtracting 2, so I can combine the constants, -16 and 2. And the last step was division. Now, if you look at the table down below, these are called algebraic properties of equality. So what I did for the first step is I used the addition property, meaning that I added something to both sides. Then the second step, I used the subtraction property, meaning I subtracted something from both sides. And the third step, I used the division property, meaning that I divided both sides by something. So that's what we're going to be talking about today, is like all the algebraic steps we do to solve these problems. And usually, sometimes we just kind of go in a sort of an automated mode where we just say, oh, yeah, we add 3x both sides. Oh yeah, we subtract 2. Oh yeah, we divide 9, and that's that. But we're going to be a little more deliberate with stating each step. Now, I'm going to just close this down. Okay. So, oh, sorry. Let's close that again. All right, there we go. So the next step, I'm going to divide everything by -4. And then add 8. So you get x equals 12. That should be pretty straightforward. And what I did here is I did the division property and then the addition property. And then here, again, you're asked to solve for x. It's a little strange because you see a bunch of letters, but you can subtract 2m because the whole point is to get x by itself anyway, right? And then divide 2. You can leave it like a big fraction like that. So what I did here is I did the subtraction property, then the division property. So again, we're isolating x in these problems here. And also we're going to state the properties that go with each step. Hopefully the first 4 seem pretty easy. If you add something to both sides, again, you're going to say addition property. If you're subtracting something from both sides, you're going to do, say, subtraction property. If you're multiplying the same thing to both sides, you're going to say the multiplication property, dividing both sides by something, you're going to say the division property. And the substitution properties, if you're replacing a letter with something else. We'll see that down the road. Okay, so let's look at 2.5.1 and 2.5.2. You have to write a reason for each step. So here, again, I want to, if I add 3x to both sides, so then you get this, 5x equals 20. Then I want to divide both sides by 5. You get x equals 4. So the first step was given. We call it step 1. Then the second step which is basically this right here, is going to be the addition property of equality. You got to write like that, actually, to kind of show the equal sign. And then the third step was a division property of equality. And actually, let me redo that because that's a little bit ugly the way I have it right now. So let's add 3x. You got that. So again, that's step 1. We'll call it step 2, addition property of equality. Then I repeat 5x equals 20 and show that I'm dividing both sides by 5 to get this. And that's division property of equality. So what you want to do is show what you're doing in terms of what you're doing to both sides, and then what the result is within the same step. So that's just we call it a 3-step proof. So this is a proof, believe it or not, because you're proving why x has to equal 5. So, oh, I'm sorry, I meant to say 4. Oh my goodness. You probably thought I've lost my mind. 3y x equals 4. It's early in the morning. All right. Now, we did something kind of like this in the warm-up up above. But you could have also distributed as well. And then subtracted 32, and then divide by -4. So that's it. That's another pathway you could take, which we're going to do over here because you're asked to use the distributive property. So first step, we'll state what we're given. And that's going to be something you're always going to do with proofs. Always state what you're given. In the second step, we're going to distribute. Now we just call it the distributive property, meaning that you're multiplying -4 to both 11x and 2, which you're allowed to do. In the third step, I'll add 8 to both sides. You could probably do it all in one line if you like. Which of course looks like this. So that's called the addition property of equality, because you're adding something to both sides. And the fourth step we call it the division property of equality. Of course, that's a sus. So we're going to be getting the habit of writing these things out, because we're going to have to do this for geometric shapes. We're going to have to prove like why maybe 2 sides equal each other, 2 angles equal each other, given some information. Let's look at page 2 here. A farmer's planting growing grapes on his triangular shaped lot. Look, the farmer already knows the total area of his lot and spent some time measuring the height of his lot. Save some time, he just needs to do some math to find the base, solve the equation. Okay. So you have to isolate B. Well, I kind of know that I have to do a couple steps, but let's go and write this out. So we'll state the original equation. That's given. Then we're going to multiply both sides by 2. So I'm going to rewrite the equation here. Which just becomes this now. That's the multiplication property of equality. So I multiply both sides by the same thing. And 3, I'm going to divide both sides by h. Which is going to be 2a over h equals b. So that counts. So that's where we separate all the steps. So that's that one. We have some more properties here. Here you have something we call reflexive property of equality. And that just means you say something equals itself. I know it seems kind of weird. Trust me, we will need to do this and often in geometry, especially these two here. Symmetric means that you just reverse the letters on each side of the equation, or reverse the two sides. We don't really do that too often, but sometimes it could help. But definitely these two are very common. And transitive means if A equals B and B equals C, then A equals C. It's kind of like saying, for saying the Warriors beat the Kings beat the Lakers, so the Warriors beat the Lakers. I know that doesn't really work in sports, but that's what transitive means. So you can kind of see that down below. We don't really do those too often. Sometimes we do, but I say it's quite common, but we don't do it too often. The reflexive we do a lot. And you'll see when we start doing more geometric proofs with shapes and stuff like that. Anyway, so here you're being asked to simply name the property of equality statements. So measure of angle 6 equals measure of angle 7, so 7 equals 6. That's going to be transitive property of equality for angles. C is just going to be reflexive. Reflexive property. And it does get to be a bit redundant to write property of equality. So I'm okay if you just said reflexive for angles. I'm okay with that. If you look at F here, that's going to be symmetric. For angles. E is going to be symmetric for segments. Symmetric means just swap the two. R equals T, T equals P, R equals P, that's transitive for angles. And finally, JK equals KL, K equals 12. So JK equals 12, that's transitive for segments. Okay, so we've talked about some reasons and properties, and that concludes the video for 2.5.